What is up, everybody? All right, we are moving into Unit 7. Now we're going to start with 7.2 because 7.1 was dilation, and we did that when we covered transformations. So we jumped straight into 7.2, and this unit is all about similar figures. So previously we've done a lot about talking about congruent figures. Now we're going to move on to similar figures. Okay, so before we do that though, let's just quickly review what congruent figures are. So remember, if polygons are congruent, then all corresponding sides and angles are congruent. So if I had this triangle right here and ABC was congruent to DEF, then I know that A is congruent to D, because remember, the order that it is written in is very important, right? It's in corresponding order. So A and D are the first letters of the statement. So I know that angle A is congruent to angle D. And using that same theory, I know that B is congruent to E and that C is congruent to F. We also then know that AB is congruent to DE, BC is congruent to EF, and AC is congruent to DF. And again, guys, we can tell all of that by remembering corresponding order when we make our congruent statement. Now when we move into similar polygons, okay, some of the stuff's going to transfer over, some of it's not. So the big difference between congruent polygons and similar polygons is similar polygons are the same shape. However, they are a different size, okay? So remember when we did dilations and we were either shrinking or enlarging figures, but the actual shape of the figure was not changing? That is creating similar figures via dilation, okay? And so what's nice about similar figures is that the corresponding order, the way that we make the statement, stays the same. And so as this is our symbol for similar. It's what goes on top of the equal sign in congruent statement, but just that. So you'll see this. So like if triangle ABC is congruent to DEF, it would be triangle ABC is similar to triangle DEF. Okay. So you'll see examples of that throughout the notes today. So if two polygons are similar, so ABCD is similar to WXYZ. Notice how I had that statement right there, that symbol right there in the middle. Then we know that all the corresponding angles are congruent. So just like a congruent statement, a similarity statement is written in corresponding order. So I know then that A is congruent to W, B is congruent to X, C is congruent to Y, etc. So we can make all of these markings then right here. Okay. Now the difference between similarity, right, and congruence is that the sides aren't the same length. However, the sides are what we call proportional. And this is going to be the most difficult part of the similarity, is grasping how to write these ratios. Okay, so guys, a ratio is when we compare two things, right, like A to B. But a ratio can also be written as a fraction. And that's how we're going to write our ratios for similarity. Because ratios play a huge part, because the two figures are what we call proportional. And what proportional is when two ratios equal each other. So now that I've put in side lengths for each figure, we have to put together the ratios. And the way that I always like to do the ratios is I like to do corresponding side ratios. So if we look at our similarity statement right here, I know that AB corresponds to WX because it's the first two letters in each shape. So when I make my ratio, I usually do a left over right ratio. So I'm going to do the left figure over the right. So I'm going to make my corresponding side ratio because corresponding sides are proportional. So AB over WX. So again, I'm not putting in the numbers just yet, okay? I'm just showing you how the ratios work. Now, every corresponding ratio is going to equal every other corresponding ratio, and that is the definition of proportional, okay? Just think about when somebody's doing a painting, right? They have to make it proportional. They have to shrink each part of the picture the exact same amount, or else it doesn't look right. It looks disproportioned. So then BC goes with XY, because again, those are the second and the third letter in our statement, and then we could kind of just keep going right here. So because these two figures are similar, that means the corresponding ratios are equal, which makes it proportional. So now let's go ahead and plug in the numeric values for each of these segments. Okay. And so what I did was I did the length of AB over the length of WX, BC over XY. I just took all the lengths from our diagram on the left, and I just substituted them in for the name of their segment on the right. And so notice that each one of those fractions looks like a different value, right? Because it has different numerical lengths. However, when we reduce all of them, it turns out to be the same numeric value. 15 over 5 is 3 over 1. 12 over 4, 3 over 1. And when we reduce those ratios, we get what's called the scale factor. And the scale factor is kind of that reduced amount that tells us just the exact relationship of the lengths between the figures. So what this is saying with our scale factor of 3 to 1 is that the figure on the left is 3 times bigger than the figure on the right. So for every 1 unit on the right, there's 3 units on the left. Now, if those ratios are not equal, okay, so see how we have 4 different ratios, 4 different fractions. If they're not equal, then the figures are not similar. Okay, so that is the number one concept. Besides corresponding angles being congruent, which is kind of an easy transition, the number one thing to remember is that corresponding ratios are equal, aka they are proportional. So if I looked at this figure right here, okay, they're giving us the similarity statement. They're telling us that FGH is similar to JLK. And so what I'd like you to do is just take a second, pause this, name the congruent angles, and then practice putting together the ratios and making them equal. Okay, so pause this right now. Okay, so now when I do this, right, I can just go ahead and make my congruent statement. So I know that angle F is congruent to angle J. I know that angle G is congruent to angle L. And I know angle H is congruent to angle K. Okay, and again, I don't even need the diagram for that. I can just look at this right here, and that's that corresponding order. So I can just kind of just do this now. Now, the other thing I want to do now is I want to create my ratios. So I'm going to have FG, which corresponds to JL. I'm going to have GH, which corresponds to LK. And then I'm going to have FH, or HF, I guess if we want to go kind of from back to forward, HF, which corresponds to KJ. And so those are all of our corresponding ratios. And because these figures are similar, those ratios are equal. So now how do we use this to solve for missing pieces? So it says, are the two triangles similar? So notice we're not given now a similarity statement. We kind of have to piece this together based off the diagram's information they give us. So I know that angle N is congruent to angle R. I know that angle Q is congruent to angle S, and then by default, angle P will now be congruent to angle T. So we need to put together our corresponding ratios. So the way that I would recommend this is pick a side. So I'm going to pick 12.5 right here, and because that's between our single dash and our double dash angles. And so I'm going to pick 12.5, so I'm going to be making ratios left over right. So the lengths on the left over the lengths on the right. So now on the right, I'm looking for the side length that's between the single dash and the double dash angle. Single dash, double dash, which would be side length 10. And once I've kind of established a direction that I'm going, it's going to be pretty easy. So now I do 11.5. I'm just working clockwise around my triangle on the left. And then so I've got a double dash and a triple dash, which would then be my 9.2 on the right. And then by default, I only have one more side left, so 15 over 12. Now there's decimal amounts in here, so you're definitely going to use a calculator when comparing these ratios. So all I would do in a calculator is do 12.5 divided by 10. It gets me 1.25. 11.5 divided by 9.2, that gets me 1.25. 15 divided by 12, 1.25. So notice that all of those ratios came out to be the exact same thing. So the answer to the question, are the two triangles similar? Yes, because number one, all three angles are corresponding angles are congruent, but also because the side lengths are proportional. And we know it's proportional because the ratios are equal. Okay? Looking at this one here, now we're solving for x and y. So this is where the ratios are going to come into a little bit more of effect. So they're giving us our similarity statement. So without even looking at this diagram, we know what's corresponding. So now let's think, okay, well, I have AF. It's supposed to be an F. I don't know why it's a P. So this is supposed to be an F right here. So I know that AF is my first and my last letter. So I'm going to say AF, which is 12, first and the last letter, V and Z. V and Z is 3y minus 1. Okay. CD. CD is my middle two letters on my top one. My middle two letters are WY. So 9 over WY is 6. Now notice, guys, I'm staying consistent. I'm always putting shapes from this one on the top and numbers from the top, the numbers from this segment on the top, numbers from this segment on the bottom. And then finally, we have FD, which is represented by this X right here. So FD is X, and then FD is our last two, YZ is 10. So notice that we only have one ratio that actually has both numbers and not a variable. But remember, these figures are similar, so we know that all the ratios are equal. So what we can do here is we can break this up into two equations. I can do 12 over 3y minus 1 equals 9 over 6. And I can also do x over 10 equals 9 over 6. And so the goal is to now have two equations. Each equation has its own variable. And whenever we have a fraction equal a fraction, we can just cross multiply them. So what I can do now is I can do 9 times 3, which is 27y, minus 9 equals 12 times 6, which is 72. Add the 9 to both sides, 27y equals 81. 81 divided by 27 is 3, so y equals 3. For the next one, cross multiply, I get 6x equals 90. 90 divided by 6 is 15, so x equals 15. So as you can see, guys, understanding the whole ratios and proportions, super important for this unit, okay? Another question, another example. Okay, so it says JLM is similar to QST, find x and y, same exact concept. Okay, so maybe pause this one and then try and do it on your own, then come back. Okay, so single arc, double arc, 4. Single arc, double arc, 2. Single, double, single, double. Double to no arc, 6x minus 3. Double to no arc, 3. No arc to single, 3y minus 2, 5. So remember, these are all equal. So now, here's my ratio. Now, some teachers will tell you to reduce that before you solve. It's honestly not that big of a deal because you're going to be multiplying and solving for x anyway and y. So 4 over 2 equals 6x minus 3 over 3. 4 over 2 equals 3y minus 2 over 5. And then now it's just like the previous problem we did. We're just going to cross multiply. So I'm going to get 12 equals 12x minus 3. Add the 3, 15 equals 12x. So x is going to equal 15 divided by 12. Reduce that by 3, 5/4. Cross multiply, 20 equals 6y minus 4. Add the 4 to both sides. 24 equals 6y. So y equals 4. Okay? Now the last thing that I want to talk about is the perimeter of similar figures. So if two figures are similar, then the scale factor is equal to the perimeter ratio. Okay? So when two figures are similar, not only are corresponding sides equal, but also the perimeter ratio is also equal to the scale factor as well. Okay? So here we have two triangles, WZX and SRT, and we know that WX corresponds to ST, so we have a ratio of 5 over 6, or our scale factor is 5 over 6. It's already reduced. Now, if the perimeter of triangle SRT is 15, then the perimeter of WZX is what we're going to try to find. All right. So I'm just going to call it X for right now. Now notice in our scale factor we did 5 over 6, or a left over right ratio. Our perimeter ratio is going to be the same thing, left over right. The perimeter of the triangle on the left over the perimeter of the triangle on the right. And so all we do is make our scale factor equal to that ratio, and then we can just cross multiply. 6x equals 15 times 5 is 75, divided by 6, x is 12.5. So the perimeter of that triangle right there is 12.5. Good luck on the homework. Let me know if you have any questions.